Before we dive into what a thermite reaction is, first we should try to learn the history of how it was discovered. Thermite was first discovered in the 19th century by a German chemist named Hans Goldschmidt. Hans Goldschmidt was attempting to refine metals without the use of carbon. Thermite reactions are used for the welding of rails or fusing different metals together.
A thermite reaction is the ignition of aluminum with ferric oxide. This is an exothermic reaction where heat is released along with its end products.
This reaction first begins with the presence of ferric oxide, an ionic compound by itself, which because iron is a metal and oxygen is a nonmetal. The reason for the amount of each element here has to do with the charges, as iron is a cation and has a charge of positive 3, and oxygen is an anion and has a charge of negative 2.
And when aluminum is in close proximity to ferric oxide, it gets drawn to this ionic compound, getting ready to transfer electrons to oxygen.
And when they merge, the reactants undergo a single replacement reaction, meaning iron is split from oxygen and the presence of aluminum replaces that of iron, thus having iron separated like aluminum originally was. And so a new compound is formed, aluminum oxide.
This new arrangement of the reactants make up the product, but still remain unbalanced. On the reactant side, there are 2 atoms of iron, 3 atoms of oxygen, and 1 of aluminum. However, on the product side, there are 2 atoms of aluminum, 3 atoms of oxygen, and 1 atom of iron. The unbalanced equation for the thermite reaction is ferric oxide, and aluminum react to form aluminum oxide and iron.
The fact that everything else remains unbalanced with the exception of the amount of atoms for oxygen tells us that this equation needs balancing, so we need to add some coefficients in order to match the quantity of atoms on both sides for iron and aluminum.
So, as we identified aluminum and iron are the elements or atoms that need balancing, we need to pick one or the other to balance first. In this case, we picked aluminum to balance first. There are 2 atoms of aluminum on the product side, so we need to put a 2 as the coefficient for the aluminum on the reactant side. Therefore, aluminum is balanced as there are the same amount of atoms of this element for both sides. This is a single replacement reaction. This means that aluminum is isolated by itself on the reactant side, and iron being isolated on the product side. And this leaves iron with oxygen for the reactants, and aluminum with oxygen for the products.
Now the only thing left to balance is iron. On the reactant side, there are 2 atoms of iron and only 1 atom of the element for the product side. The iron atoms, which are part of the reactants, don't need balancing or further adjustments, as we can put out a 2 for the coefficient of iron in the products.
Now that all these steps are finished, the reaction is finally balanced. And this is because the amount of atoms for each element on the reactant side are equivalent to those that are part of the products. However, one thing to take note or be aware of is how heat is produced during this reaction as a product, which results in a lot of energy being released, and the iron produced from the cycle is in liquid or molten states.